On a museum table in Germany, a bronze object sits no larger than a grapefruit. It has 12 flat faces, strange knobs at its corners, and a neat pattern of circular holes, each one a different size. Its surface is green with age, but the workmanship is careful enough to suggest a skilled Roman craftsman, not a forgotten tool tossed into a furnace. Hold it in your hands, and the problem begins. There is no blade, no handle, no inscription naming its purpose. It does not open, measure, cut, or lock in any obvious way. Every surface seems to promise an answer, then withhold it. So what was it for? Now multiply that single object by more than 100. They have appeared in forts, villas, graves, wells, and the buried floors of Roman buildings from Britain to Hungary. Some are tiny. Some are large enough to fill a palm. None arrived with instructions. 2,000 years later, the Romans have left us the object and erased the user. At Niederbieber, the object did not emerge from a palace or a philosopher's study. It came from the remains of a Roman military settlement on the Rhine, where stone walls, barracks, and workshops had collapsed into layers of dark soil. The fort stood near modern Neuwied, guarding a frontier that was never as quiet as Rome's maps suggested. During excavation, bronze appeared among the ordinary debris. Nails, coins, fittings, fragments of military equipment. Then the soil gave up something that did not belong to any familiar category. It was hollow. 12 flat faces formed its shell, each pierced by a circular opening. Around every corner sat a small rounded knob, 20 in all, like bronze rivets placed where no rivets were needed. The surface was worn and green with age, but the object had not been crushed. Its openings were still clear. Some were wide enough for a finger. Others were much smaller. No two seemed to follow a simple pattern, and the knobs did not make it easier to understand. They made the thing look finished, deliberate, almost engineered. The first explanation was practical and domestic. A candle holder. A flame could sit inside the hollow body while the openings allowed air to circulate and light to spill across a room. The idea had an immediate appeal. Roman households needed lamps, and bronze objects with holes were hardly unknown. But the object resisted the comparison. A candle placed inside would have no stable base. The many openings would expose the flame from every direction, and their varying sizes seemed excessive for ventilation. Why build 12 faces when a simple lamp could do the same work with less metal and less effort? Then came measurement. Perhaps it was a surveying instrument or a device for judging distance. The different openings could frame targets at known ranges. The knobs might hold cords, rods, or a sighting arrangement that had vanished over time. That theory found support in the metal worker's precision. The holes were not random punctures. They were shaped, aligned, and surrounded by carefully formed faces. Yet, when the Niederbieber example was set beside other discoveries, the measurements stopped behaving like a single system. The openings changed from object to object. Their proportions shifted. Even the size of the bronze bodies varied. A candle holder was too simple. A measuring device was too inconsistent. And the more examples archaeologists placed on the table, the stranger the original find became. The objects have a name, though the name explains almost nothing. Archaeologists call them Roman dodecahedra, hollow bronze bodies with 12 pentagonal faces, circular openings, and small knobs projecting from their corners. No two are perfectly alike. More than 100 have been recovered across the northern Roman world, from Britain and Gaul to the German frontier, the Low Countries, and beyond. Most date between the 2nd and 4th centuries A.D., when Roman soldiers, traders, and civilians moved through these provinces. They turn up in forts, settlements, graves, hoards, and occasionally in fields far from any obvious setting. Some are tiny enough to fit in a hand. Others are large, heavy, and richly decorated. A few still carry traces of wear. Many do not, yet no Roman writer names them. No surviving inscription identifies their owner. No workshop manual describes their operation. The empire left behind roads, laws, coins, and engineering instructions. For this object it left silence. The Roman dodecahedron is not a puzzle with one missing page. It is a puzzle with no known title, no known user, and no agreed first move. The object seems to invite a practical answer. It is small enough to hold in one hand, heavy enough to feel deliberate, and shaped with a precision that suggests somebody knew exactly what they were making. But that precision only deepens the problem. Most faces contain an opening, and those openings are rarely identical. One may be broad enough for a finger. Another may be little more than a narrow ring. The knobs keep the object from resting flat on its faces, making the whole thing look less like a container than a cage. Almost every feature appears useful. The features simply refuse to agree on what the use was. The candle holder theory has a straightforward starting point. A hollow bronze body with holes could protect a small flame while allowing air to circulate. The knobs could lift it above a surface, and a candle might sit inside the largest opening. Some dodecahedra were found with traces interpreted as wax or soot, but those traces can also come from burial conditions, later handling, or nearby fires. Then the shape begins to resist the idea. A candle holder does not need 12 differently sized openings. It needs one stable socket, perhaps a few vents. The dodecahedron offers no obvious flat base, and its many holes would expose a flame from every direction. A replica can be made to hold a candle, but that proves only that bronze can surround a flame. It does not explain the peculiar geometry. The surveying theory uses those holes differently. Look through two openings on opposite faces, and the object starts to resemble a sighting device. The knobs provide handholds. Different diameters might accommodate different viewing distances or frame a distant landmark. On a modern replica, a straight line through two holes creates a surprisingly narrow field of vision. But a Roman surveyor needed repeatable measurements. These objects do not behave like calibrated instruments. The holes are not consistently paired in a simple sequence. Their dimensions vary from one example to another. There are no marked scales, pointers, crosshairs, or fittings for a staff. Geometry can show where a line of sight passes. It cannot show that anyone read a distance from it. That weakness also undermines the range-finder proposal. In theory, two holes with a known separation can create a visual triangle. If the viewer knows the angle between the sight lines, distance can be calculated. Yet the surviving objects rarely provide a fixed baseline or a clear way to hold the eye in one position. A replica may produce a number once. A useful field tool must produce the same number every time. The strangest proposals are domestic. Several holes could guide knitting, perhaps producing gloves or small tubes. Others suggest a tool for shaping fingers in leather gloves. The different hole sizes seem to support the idea. Each opening might match a different finger width. Its compact form would also suit a craftsperson carrying it in a pouch. Still, the holes are arranged across every face, not in an easy working row. Their edges can be sharp. The knobs interrupt the hand. To knit a tube, someone would need tension, a needle, and a way to anchor the thread. The bronze shell supplies none of those. Glove making faces the same problem. It explains why sizes might matter, but not why those sizes are scattered across 12 faces. Perhaps it was a measuring device. The openings could gauge rods, fingers, cords, or small objects. The knobs might mark positions, while the repeated form suggests a standard tool used across many sites. Manufacture makes that possibility tempting. These were not one-off curiosities. Bronze workers produced multiple examples with broadly similar proportions, even though no two are perfectly alike. Yet a measuring tool normally carries its measurement in a form someone can read. A scale, a known interval, a marked unit. Here, the evidence is mostly shape. Researchers can calculate what each aperture might admit, test how two holes align, or watch how a shadow moves inside the shell. Replicas can show whether a flame stays lit, whether a sight line is usable, or whether yarn catches on the edges. Those tests separate physical possibility from practical usefulness, and that is where the dodecahedron becomes so difficult. Every theory explains one clue beautifully. None explains all 12 faces, all those unequal holes, the corner knobs, the hollow body, and the repeated production at the same time. The map of the finds creates a new problem. These objects were not scattered evenly across the Roman world. Most come from the northern provinces, Britannia, Gallia Belgica, the Germanies, Raetia, and the lands along the Rhine and Danube. A few appear farther south and east, but the dense band runs through the colder, militarized edge of the empire. Rome left cities, roads, and coinage across the Mediterranean. Yet dodecahedrons gather most thickly where forts, river ports, and frontier settlements pressed against non-Roman communities. A bronze object could have traveled with a soldier, a merchant, a magistrate, or a family moving along military roads. The map cannot tell us which of them carried it. It can tell us where the object belonged to somebody's world. The dates widen the mystery instead of narrowing it. Finds and associated layers place examples across roughly the 2nd through 4th centuries A.D. This was not one brief fashion tied to a single emperor or campaign. It was a long-lived tradition, passing through generations while the Roman frontier shifted, hardened, and began to fail. At Niederbieber, the dodecahedron came from a military environment near the Rhine. Other examples surfaced around forts and garrisons, where bronze tools, weapons, harness fittings, and personal objects collected in the mud and rubble of army life. But the army cannot claim them all. Some came from settlements, villas, workshops, and urban deposits. Others turned up near burials, sometimes as grave goods or beside funerary remains. That variety blocks every easy answer. Lay several of the bronze objects across a worktable and the resemblance is obvious. 12-sided frames, knobs at the corners, rings around the openings. Then the measuring begins. The arms are not identical. The holes do not follow one dependable sequence. The thickness shifts. Even the proportions wander. If these were standard military tools, that is a problem. Official equipment usually leaves a pattern, repeated dimensions, recognizable fittings, a clear relationship to weapons, clothing, or surveying gear. If they were household tools, their presence near forts could be explained by cooking, trade, or ordinary domestic life. But the objects are rare. If they belonged to religious practice, finds near graves might seem promising, until settlement layers and military sites pull the evidence in other directions. The map opens another possibility. Bronze goods moved along the Rhine and Danube, packed into carts, carried on river boats, and exchanged in markets outside the forts. A craftsman in a provincial town could copy an object made hundreds of miles away. A trader could carry the finished piece from a workshop to a military settlement, an estate, or a roadside market. The design could travel without a single workshop in Rome controlling it. That would explain the resemblance. It would not explain the differences. One maker may have started with a borrowed model, then changed the openings to suit local habits, available molds, or the customer standing in front of him. Another maker copied that altered version. After several generations, the outline remained recognizable, while the original purpose became harder to recover. The bronze could preserve the shape of an idea even after its instructions had vanished. This is why some scholars have considered local production in the northern provinces. The metal was familiar. Provincial workshops already cast fittings, vessels, tools, and ornaments. A maker did not need an imperial order stamped on a tablet. He needed a model, a customer, and enough skill to reproduce the awkward geometry. But the scattered finds also allow a more elusive possibility. Perhaps these belong to a small group that moved from settlement to settlement. Surveyors, astrologers, craftsmen, healers, priests, or specialists, whose work left little trace. The objects might have traveled in a leather bag rather than sitting permanently in one workshop or shrine. No burial has produced a clear professional kit. No inscription names a guild, office, or occupations linked to them. The proposed users remain shadows crossing the same map. The distribution tells us something, but not the thing we want most. More than one community knew how to make these objects, and the design crossed distance and time. That does not mean every owner used one in the same way. A common shape can travel farther than a common meaning. So the investigation turns from the map to the objects themselves. Put them side by side. Measure the length of each arm, the diameter of every opening, the thickness of the bronze, and the spacing between the rings. If they were instruments built for one precise task, their dimensions should gather around a working standard. A cord maker's gauge should produce repeatable measurements. A surveying device should fit a consistent system. A calendar instrument should not depend on which provincial workshop happened to cast it. Yet the surviving pieces refuse to line up. Some are small enough to sit in a palm. Others are broad, heavy, and awkward to grip. Their holes vary. Their proportions drift. That does not make practical use impossible. Ancient tools were handmade, and handmade tools can be irregular. But it weakens the idea that every object performed the same exact operation. Then comes the harsher test. Wear. A tool dragged repeatedly over leather should polish a predictable ridge. One pressed against wood should flatten its corners. A device used to measure thread should gather scratches along the parts that did the work. Under microscopes and three-dimensional scans, researchers look for those trails, the tiny record of a hand repeating the same action hundreds of times. Some dodecahedra are damaged. One opening may be battered while another remains sharp. A ring may be bent, broken, or missing. But the expected pattern often fails to appear. There is no consistent abrasion concentrated on the supposed working parts. Corrosion can hide the surface so the evidence is never perfectly clean. Still, across a large collection, the same absence keeps returning. The objects look used. They do not consistently look used as tools. Metallurgy adds another filter. Analysis can reveal the proportions of copper, tin, lead, and trace metals, along with casting flaws and repairs. The results do not point to one master mold. Some pieces were carefully finished. Others are rougher, their sprues clipped away, and their surfaces left uneven. That fits scattered production. It does not reveal a specialized workshop turning out standardized equipment. Scans also fail to uncover hidden mechanisms, calibrated interiors, or markings that would transform the hollow frame into a readable device. The bronze contains evidence of how it was made, but not a label explaining what it was for. Experimental archaeology carries the theories into the real world. Researchers cast replicas, attach cords, place them over candles, use them as knitting gauges, and try them as surveying aids. A replica can be made to work in a demonstration. A smaller hole can guide a thread. A candle can sit inside the open frame, but then the experiment exposes its weakness. Change the size of the replica, and the method changes. Use a different cord, and the handling changes. Adjust the lighting or the angle, and an object that seemed useful a moment earlier becomes awkward. Each proposed function begins to require its own special version of the artifact. That is not a discovery. It is a warning that the explanation may be chasing the object. The same problem follows ritual theories. A dodecahedron could have served divination, astrology, or ceremony. Its 12 faces invite symbolic readings, and some examples came from graves, buildings, or military sites. But those categories are wide enough to contain almost anything carried by people through the empire. A grave deposit might mark status, preserve a personal possession, or represent a final offering. A military site might contain equipment, merchandise, household goods, or an object dropped by someone passing through. Without repeated placement beside altars, offerings, inscriptions, or distinctive ritual debris, the sacred explanation remains possible, but it still has no instructions attached. Statistics sharpen that distinction. When hundreds of finds are plotted by size, location, date, and context, researchers can ask whether a real pattern rises above chance. Do certain hole sizes occur only in military zones? Do larger examples belong to a particular century? Are damaged rings linked to one proposed use? So far, the answers resist a neat design. The collection contains tendencies, but not a stable signature. And then there is the silence around them. No Roman writer describes the objects. No surviving image clearly shows one in use. No workshop has been identified with molds, rejected castings, or a matching set of tools. No inscription says who owned one or what it did. That silence cannot prove that the dodecahedra had no purpose. Smutch M. Organic instructions vanished. Private customs were rarely recorded, but every missing connection narrows the claims that can safely be made. Archaeology does not replace the mystery with a single answer. It makes the easy answers more expensive. That may be the point at which the question itself begins to mislead us. Researchers keep asking, what was the dodecahedron for? As though every object must belong to one familiar category: tool, weapon, instrument, container. But some objects do not function alone. Their meaning lives in who handles them when they appear, and what other people understand when they see them. A bronze dodecahedron could have marked expertise, without performing a task that leaves measurable traces. It might have belonged to a specialist whose authority came from knowing the gestures, materials, or words that accompanied it. A local ritual official, a maker of gloves or cords, a member of a small community whose customs never spread far enough to enter Roman literature. That would explain the frustrating mixture of clues. The objects are carefully made, yet often found without workshops. They are valuable, yet not valuable enough to attract a standard inventory. They appear across distant provinces, but not in a uniform pattern. Their forms repeat just enough to suggest a shared idea, while their dimensions and decoration drift from one region to the next. A familiar Roman tool should leave familiar companions. Scraps, working surfaces, repairs, specialize waste. Instead, some dodecahedra turn up in hordes, others in graves, others in places where their original setting has been damaged or erased. A bronze shell survives. The cord it touched rots away. The wax, cloth, pigment, or plant fiber disappears. The person who knew the sequence dies without writing it down. What remains is not necessarily a broken machine. It may be the surviving piece of a larger practice. If the object was a measuring device, testing it means asking whether its holes produce reliable measurements. If it was a badge, a ritual implement, or an item recognized inside a closed circle, that test misses the point. Its success may have depended on an audience. The right person held it. The right material passed through it. The right ceremony made its presence meaningful. This kind of knowledge can vanish quickly. A workshop closes. A family line ends. A regional custom is absorbed into a larger culture, leaving its bronze symbols behind, but not its instructions. Centuries later, the artifact looks like a puzzle because the social world that made it legible has gone missing. The dodecahedra may not be failed versions of an ordinary tool. They may be evidence of a technology made from hands, habits, and recognition. One, that bronze preserved only after everything else had disappeared. Each new discovery can narrow the mystery without unlocking it. We can measure the sockets, compare the rings, trace the alloy, and place each fragment on a map from Britain to the Danube. We can follow the seams of corrosion and see the marks left by casting. But the crucial moment happened somewhere else. A hand lifted the bronze, a material passed through one opening, and someone nearby understood what that gesture meant. That is why the object feels so complete and so empty. The metal survived. The shared knowledge did not. Its holes still have diameters, its knobs still carry their patterns, and its surfaces still record the work of ancient hands. What vanished was the human agreement that turned those features into an act. The Romans may not have left behind an unexplained object at all, but an explanation that was meant to disappear with the people who knew it.